I will travel across the land. 7.5 log equations. Let's start solving some equations that require you to use logarithms. All right, solving perfect bases. If the bases match up, you can cancel them. So for example, we have 5 raised to the 3x power equals 5 raised to the x plus 8 power. All right, so the whole point of using logarithms is because we need to solve equations where the variable is in the exponent. In this case, we have a variable in the exponent, but because the bases match up, they're both 5s, they don't necessarily cancel out, but they act like if they're the same bases, that means their exponents must be the same. So you just have 3x is equal to x plus 8, which becomes a very basic algebra problem. X equals 4. All right, so again, when the bases match up, you can kind of cancel them out and just set the exponents equal to each other. Sometimes the bases do not match up, like this one. This one has a base of 2, but this one has a base of 32. All right, so when that's the case, maybe you can make the bases the same. So the question is, how do I turn 32 into a 2? Is there a special way I can write 32 so that it has base 2? And there is a way. What about 2 to the 5th power? 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. All right, so 2 to the 5th power is a different way of writing 32. But we're doing it that way just so that now they both have base 2. All right, let's simplify it. The 5 in the x makes 5x. Let's go ahead and cancel those out, and you're left with just x plus 20 equals 5x. Pretty easy algebra 1 problem. Solve it out, you get x equals 5. Here's another one. It's the same thing as the last one. How do you change this 4 to make it a 2? Well, obviously we know 4 is the same thing as 2 squared. So there it is, 2 squared. Go ahead and simplify this part, multiply them together, and then you just cancel out the 2's. You have 7x is equal to 2x plus 10. Easy algebra 1 problem. X equals 2. All right, so that's an easy way when you can get the bases to be the same. But sometimes the bases are not going to be ever be made the same. Like you have a 10 and a 35. You can't make a 35 so it has base 10. So what we're going to do is use logarithms. All right. This right now is an exponential form. 10 to the x power equals 35, exponential form. Go ahead and turn it into logarithmic form. Remember the definition of logarithms? It was way back in one of the first sections in this chapter. But to change it to log form, we did that whole thing with the left, right, left. So base 10 of 35 equals x. All right. From here, on your calculator, your graphing calculator if you have one, it is base 10, so there's a log button right here. It's right next to the 7, the number 7. If you punch in log of 35 into your calculator, it knows that it is base 7. So the answer is going to be 1.5441. Go ahead, punch it in your calculator right now to see if you can get that. You should. Here's another one. It's an exponential form. Obviously 53 cannot be changed somehow to be 7.2. So go ahead and put it in log form. There it is. There's log form. But if you notice, this example is not base 10. All right, so when it's not base 10, you have to do something else. You can't just use the log button. For those of you guys who have a newer graphing calculator, you can go to the math button. There's a math button right here. And then once you go to the math button, you scroll down until you see something that says log base. It's like if you scroll down quite a bit, you'll see something that says log base. I don't know if you can see it on my calculator, but it's that last option right there. Okay, if you have a newer calculator, you can use log base and the calculator will do a different log that's not base 10. If you don't have a newer calculator, you can do the change of base formula. We did cover the change of base formula already. That's this one, log of 53 divided by log of 7.2. And that automatically puts you in base 10. Punch them into your calculator. There's our answer. Okay, try it. Practice the keystrokes on your calculator. Make sure you have the same answer I do. This one says trickier. Solve using your calculator. All right, so this is in it's an exponential form. The exponent is in the, variable is in the exponent. Okay, so go ahead and change it to log form. There it is in log form. And then you're then going to go ahead and punch this into your calculator. Again, if you have a newer calculator, use the log base on the calculator. If you don't, use change of base. Either way, you should get 2.9746. And then there's one step after that, and that's just to divide by 3. There it is. Here's another one that's slightly more complicated. Change it to log form. Punch this into your calculator and subtract 4. Not that bad, huh? Looks like there's another one. Ooh, this one's only a little bit tricky, only because there's a 4 in the very front. What do you think you're going to do to that 4? Bring it to the other side, subtract 4 from both sides. But then we have another problem. We have negatives on both sides. Let's go ahead and multiply both sides by -1. And we have 3 to the x equals 24. Change it to log form. And then punch it in your calculator. There it is. You can barely see the answer, but it's 2.8929. All right. Oh, what about equations that have log in them already? Like this one. Log, again, when there's no base, it's base 10. So log of 5x equals 2. When they give you an equation with log in it, change it to exponential form. Again, there's an imaginary 10 that's down here whenever they don't write it. So that's why it's base 10. Base 10 squared equals 5x. It's left, right, left. And then from here, you just evaluate. 10 squared is 100. Divide both sides by 5. X equals 20. Here's another one. First thing you want to do with this one, though, is get rid of that 5. Subtract it to the other side. You should get 3. Now change it to exponential form. 10 to the third power equals 2x. Evaluate 10 to the third power. That's 1,000. Divide by 2. X equals 500. All right, one more of those. First thing we want to do, get rid of this 2 by dividing both sides by 2. You have log of x minus 1 is equal to 1. Let me erase some of that. And then change it to log form, to exponential form. And then 10 to the first power is just 10. And then you add 1 to both sides to get 11. All right, let's do one last example. It is 2 logs in it. 2 logs. All right, so what do we do when there's 2 logs on one side? Make them into 1. We learned this earlier in the chapter. To combine 2 logs to 1, when there's a minus sign in between them, turns into division. X divided by 4. Now go ahead and change it to exponential form. 10 to the negative 2 equals x over 4. 10 to the negative 2, you can throw it into your calculator, multiply both sides by 4. Answer is 0.04. I lied that was the last one, but this is actually the last one. You got 2 logs, combine them. What happens when there's a plus sign in between them? When you combine them, they turn into multiplication. So there it is. I multiplied the x with this whole thing. Turn it into exponential form. 10 to the first power equals x squared minus 3x. Notice at this point, x squared. We have a quadratic equation. X squared minus 3x minus 10 equals 0. Quadratics! We get to visit that chapter again. There's actually 4 ways to solve this equation. There's actually a few more ways to solve it, but we only taught you 4 ways. The first way, factoring, you can put them in parentheses. That's usually the easiest way. Completing the square, when you move that 10 to the other side, and then fill in the missing blank. We can also graph it on a graphing calculator or Desmos. Look for the x-intercepts, or we can use the quadratic formula. All right, it turns out that all of those methods will work for this problem. If you want, go ahead and use the factoring method because that's the easiest, but I like the quadratic formula just because it looks complicated and you get to throw a whole bunch of stuff in there. So I'll do quadratic formula. Plug it all in, simplify it a little bit. Square root of 49 does give you 7, and then it gives you 2 answers, the 3 plus 7 divided by 2 and 3 minus 7 divided by 2. And there's our 2 final answers. All right, go ahead, try the homework, see if you like it.